Hey everyone, welcome back to the channel. Today we are looking at something that genuinely surprised me when I found out a standard developer account, no admin rights, no specific privileges, just a regular identity with the Google Cloud SDK installed, getting full root access to every single VM in the GCP environment across 2 different projects. All of it in a single command. That's exactly what we are diving into today. I'll be walking you through one of the most simplest vulnerability chain I had come across in GCP environment, root SSH access via osAdminLogin. So all of it chained into a multi-hop service account privilege escalation. This is a critical rating finding. By the end of this video, you will know exactly how this attack works step by step, what the real blast radius looks like, and most importantly, how to close off this attack surface in your own environment. If that sounds interesting, stick around and let's get into it. We are going to cover in this video. We're going to move through 5 sections and each one builds on the last. First, I'll give you the background on 2 GCP primitives you really need to understand: OS login and identity-aware proxy SSH tunneling. These are legendary Google Cloud feature. The vulnerability isn't in the feature themselves, it's in how they are misconfigured. Then we'll look at the actual vulnerability, what was found, what was validated, and why the scope was so much broader than a single VM. After that, we'll walk through the final attack chain step by step, from initial SSH connection all the way through root shell, service account discovery, spinning up a rogue VM, exfiltrating a metadata token, and finally generating credentials for a third service account using the IAM Credentials API. 5 steps, fully scriptable, devastating impact. We'll also look at the full resource scope, their risk metrics, and then close out 8 concrete remediation recommendations you can take away and act on immediately. So let's start with the fundamentals. To understand the vulnerability, you need to understand 2 GCP features: OS login and IAP TCP tunneling for SSH. Let me walk you through both. So historically, SSH access to GCP compute engine VMs was managed through static SSH key pairs. Basically meaning you would need to manually add public keys to VM metadata. The OS login replaced that model. With OS login enabled, SSH access is controlled entirely through IAM roles. No more static keys, no more manual key disruptions, like Google managed the entity binding in itself. Here's what matters for today's finding. OS login defined 2 distinct IAM roles. The first one is OS login. This gives the user SSH access to a VM, but as a normal, non-privileged Linux user. Fine for developer. The second role is osAdminLogin, and this one is the completely different. This gives the user access, SSH access as a root, full root shell on that particular machine. That distinction is critical. Root means no Linux permission boundaries. Root means you can read every file, kill every process, access every in-memory credentials, and modify the system however you want. IAP's TCP tunneling feature lets you SSH into compute engine VM that has no external IP address at all. Instead of connecting directly over the network, your SSH traffic is routed through Google own infrastructure. The G-Cloud CLI handles this transparently with the tunnel through IAP flag. From a security standpoint, IAP tunneling is actually a great idea. It eliminates the need to expose SSH port publicly. The problem in that is the team often enable it broadly for developer convenience without realizing what IAM role they had actually granted. Okay, here's the key insight, and this is the sentence I want you to walk away with from this section. When OS admin is assigned to a user project and SSH IAP SSH is enabled on the project, that user get root shell on any VM within that project, where this conditions holds. Right, it does not matter if the person is a developer, tester, or service account, or used by automation. Right, root is root, and the IAM role applies project-wide. That's the misconfiguration at the heart of this finding. Let's look at what that actually looks like in practice. So let's talk about what was actually found during the security assessment. A test user identity, let's say pentest.user, was found to hold the OS admin login IAM role. That immediately flagged a problem, but the scope of that problem is what made this critical rather than just high. So what we found, IAP tunneling was reachable across both GCP project in scope. The initial validation was done on a specific staging VM. For the sake of the example, this is the name of the that staging VM. All right, one command and we had root shell. The shell come back as root, not as limited user, not required sudo, immediate root. We then query the GCP metadata API from the root shell and confirm the attached service account identity. That service account becomes your next peer point. But here's where this stops being a single instance problem. The same OS admin login role binding applies across the entire VM fleet in both projects. This wasn't just about one staging server. It was about every VM in both production and developer projects in both of them. Why it's worse than its look? Alright, so there are 4 compounding factors here. First, it's not a single host bug. The IAM model applies fleet-wide, so every VM is equally exposed. Second, at instant privilege escalation. You go from low privilege identity to root on any machines in a project with one command. Third, there is zero exploitation complexity. This uses standard documented G Cloud SDK command. No CVs, no memory corruption, no social engineering, just IAM role abuse. And last, fourth, the broad enumeration access that comes with the identity means an attacker could map the entire VM inventory and attach service account before deciding where to strike. That last point matters. When an attacker can see all your VMs, all their names, all their attached identity, they can pick the highest value target before making a single move. That recon capability is itself part of the blast radius. Now let's zoom out and look at full attack chain end-to-end before we dive into each step. This is a 6-step chain, and that's what makes it so dangerous, is that each step uses legitimate GCP API and features. There is nothing exotic here. Step 1 is the initial access, authenticated as pentest.user and IAP SSH to staging VM. One G Cloud command, and step 2 is the root shell. Because of the osAdminLogin binding, you are immediately root. So when performing who am I, you are returned as a root. You now have full control of the particular machine. The step 3 is the service account discovery. From root, you query the GCP metadata API. This is an internal CTP endpoint at 169.254.169.254. So that every Google Cloud VM can reach to. It hands back the identity of the service account attached to that VM. In this case, let's say VM SA staging. Alright. Step 4 is VM creation. This is where things escalate significantly. It's turned out VM SA staging has permission to create new compute engine instance and to attach other service account to those instances. You write a Python script using the compute engine API, create a brand new VM, you can call it anything, and specify that the highest privilege service account should be attached to it. You also embed a startup script here. Alright, so stage 5 is token theft. That startup script runs automatically when the VM boots. It curls the GCE metadata endpoint on the new VM, retrieve a short-lived OAuth access token for CI developer SA, and send it via HTTP post to an external listener. In this demo, we use the ng-rocks tunneling option. The token received, attacker now has credential for CI/CD pipeline service account. Next, step 6 is the lateral movement, the crowning step. CI developer SA has the service account, IAM service account token creation role. Alright, and which means it can call the IAM Credential API generate access token, and the endpoint on behalf of other service account. We use that to generate a fresh access token for backend runners. Third, entirely separate service account. 3 hops, 3 identity, 1 continuous chain. The blast radius banner on this slide says it all. Single non-admin identity, root across all VM in 2 projects. The service account compromise, not limited to that. Broad cloud control panel access, and this chain is fully scriptable. An attacker who discovers this misconfiguration does not need to be an expert. They need to run a script. So let's slow down and walk through first 2 steps in detail, because the simplicity here is the most alarming part. First, the IAP SSH connection. Here the exact command used in the demo. That's the initial access. 3 things are happening here. The G Cloud CLI authenticate uses using the pentest.user credential. It then opens an IAP tunnel. No SSH port is exposed to the internet, and no direct network path to the VM is needed. Google own infrastructure act as a relay, and because the IAM policy grant osAdminLogin to the identity, the resulting shell is a root shell. There is no firewall rule to bypass, no VPN to compromise, no network peering required. As long as your Google identity has the right IAM role, the IAM tunnel is enabled. Tunneling is enabled in the project. You are in. Second step is root confirmation and SA enumeration. Once inside the VM, you immediately confirm 2 things. First, privilege level, running whois command and getting back as a root. Root, not a regular user, not sudo eligible, no, not UID 1000, genuine root. Second, you query the GCE metadata service and internal HTTP endpoint available on every GCP VM to identify the attached service account. So this is the metadata URL. The metadata flavored Google header is required here. It's an SSRF protection Google built in to prevent metadata leak from web application. But from a root shell on the VM itself, we can send without any restriction. The key finding here is the VM SS staging. VM SS staging has IAM service account act as permission, meaning it can create new VMs and attach other service account to those VMs. This is critical misconfiguration that enable everything that follows. Without that permission, the chain stop here. So step 3 is where we move from simple recon into active exploitation. We are going to use the VM SS staging service account to create a brand new compute engine instance with high privilege service account attached to it, and then use the startup script to steal that as a credential. So what the script actually does, the proof of concept in the Python script using the Google API Python clients library. The same library used in countless legitimate GCP automations, and here is the flow. First, you obtain an access token from VM SS staging. You can do this directly from the metadata service on the compromised VM. That was this resulting token from this URL. Then the script calls the compute engine instance insert API to create a new VM named xfill POC in the zone US Central 1. Crucially, the API body specifies that CI developer SA should be attached to this VM as its service account identity, which would look something like this. The startup script that embedded in the VM metadata is the payload. When the VM boots, which takes around 60 to 90 seconds on the small instance, that script runs automatically as root. It installs curl, then calls the GC metadata endpoint to retrieve a short-lived OAuth access token for CI developer SA account. Yeah, this is what the curl request would look like. Yeah, that token is then immediately sent via HTTP post to the attacker external listener. Here we are using ngrocks to expose a listener on the public internet. The entire process is automated. After the script create the VM and set up the listener, you just wait for the token to arrive. Now a few things worth highlighting about why this works. The compute engine API call is entirely legitimate. VM SS staging, which was our compromised pivoted service account, is authorized to create instance. The startup script mechanism is a documented GCP feature designed for initializing tasks. And the token that comes from the metadata service is a real valid OAuth bearer token with cloud platform scope. GCP has no way to distinguish between this from legitimate automated workflow because technically speaking, at the API level, it's an legitimate workflow. This is the essence of cloud privilege escalation, abusing the legitimate permissions in a way that weren't intended. But that's the platform can't easily detect or block. This is the final and most impactful step of the chain. We now have a valid access token for CI developer SA account. The question is, what can that service account do? The answer turned out to be the ability to impersonate other service account. So Google Cloud provide an API called IAM Credentials API. One of its method is generate access token. And exactly as the name suggests, it lets a caller generate a short-lived access token on behalf of other service account. For this to work, the caller identity needs to have the account token create role, or the equivalent permission on the target service account. In this case, CI developer has the permission over backend runner. So we make this API call, which would look similar to like this, taking the bearer token of the CI developer SA account and calling for backend runner service account access token. The API returns a valid access token for backend runner. We are now from an API authentication standpoint operating as a service account. Any GCP resource that backend runner has permission on is now accessible to us. Why this is so damaging? So let me break down exactly why each of these 3 boxes on the slide matter. Right, first, why this work. So CI developer SA was a CI/CD pipeline identity. Pipeline service accounts are frequently over permissioned because they need to develop to multiple environment. Right, so the token created grants is a classic over permission that happens when teams give pipeline just a bit more access than they need. All right. Second, what it return? A real short-lived OAuth bearer token, fully functional for any API call within the requested scope. This token has an expiry of around 1 hour, more than enough for an attacker to enumerate permission and exfiltrate data. The third, the impact, we can now impersonate backend runner, whatever the identity can access, Google Cloud Storage Bucket, Cloud SQL Database, Secret Manager, secrets, other VMs, different topics is now accessible to us. And crucially, API calls made with this token appear in audit logs as backend runner, not as the original attacker identity. So that's the result. 3 service account compromised in a single chain, privilege escalation completed. Now let's map out the full scope of what's affected. Remember, all identity here are demo data for illustration purpose. The resource type and relationship reflect the real finding structure. 7 distinct resources are in scope across this finding. So demo GCP product 1 and dev 02. So this is the primary GCP project. This is where the initial SSH path was validated and where the full service account escalation chain runs. Second project, the same osAdminLogin permission model applies here too. This is the point where a single misconfiguration becomes a cross-project exposure. You are not dealing with one blast radius, you are dealing with 2. Third resource is all VM in both the project. This is the most important line in the table. The root SSH expose was not limited to a single VM, it was fleet-wide. Every compute engine instance in both projects where the osAdminLogin role was in effect. Fourth, app server staging the specific VM used to validate the initial access path. This was the entry point. 5 through 7, the 3 service account in the escalation chain. VM SA staging. The staging VM attached identity with VM create rights. CI developer SA, the CI/CD pipeline SA opt-in through the exfil VM. And backend runner, the final impersonate identity obtained via the IAM Credential API. So 7 resource, 2 projects, and a chain that converts 1 compromised user identity into 3 compromised service account and root access across the entire VM fleet. That's the scope of this finding. Let's talk about how to fix this. There are 8 recommendations here, and I want to walk through each one because they address different layers of the attack chain. Alright, restrict osAdminLogin. So the most direct fix, immediately audit who holds the compute osAdminLogin IAM role in your GCP project. Remove it from any non-administrative identity, developer, tester, service account used by automation. This role should exist in a tight control admin group only, with access reviewed and justification required. If a developer need to SSH into a VM for debugging, they should use OS login, not osAdmin login. They don't need root. Audit the entire VM fleet. Don't just fix the one VM that was validated in the testing. Run all full IAM audit across every VM in every project. The permission that enables this binding is an IAM policy binding at the project level, which means it applies everywhere in that project by default. Use gcloud to enumerate all IAM binding and look for any identity which osAdminLogin that shouldn't have it. Lockdown VM creation. The period in step 4 of the chain was only possible because VM staging service account, a VM SA staging service account could create new VMs and attach service accounts to them. That ability is controlled by 2 permissions, instant create and service account act as IAM permissions. Review who has this permission, especially service account attached to VM. If a VM SA does not need to create other VMs, it shouldn't have that permission. Removing the service account act as from service accounts that does not necessarily needs it eliminate a major class of lateral movement. Fourth, remove transitive SA trust. This is about service account architect. The finding shows a chain VM SA staging can impersonate CI developer SA, which can impersonate backend runner. That transitive trust is dangerous. Service account should be scoped tightly to their functions. A VM attached SA should have only the permission it needs for that specific workload. It should not have the ability to reach other service account in the project. But remove token creation right. The final escalation step works because CI developer SA has the service account token creation role. Audit all your service account for this role and the underlying IAM service account grant access token permission. Remove it from any SA that does not have documented, reviewed need for service account impersonation. This is a high risk permission that is frequently over granted in CI/CD pipeline. Reduce VM enumeration access. The recon phase of this attack was enabled by the test user being able to list all the VM and attach service account across both projects. A standard developer identity shouldn't have compute instant list permission on environment outside their immediate scope. Right. Project level IAM gives very broad visibility. Use resource hierarchy and folder level policies to scope access more tightly. 7th, enable high signal alerting. Detection is your safety net. Enable cloud audit logs for admin activity and data access event. Set up alert for IAP SSH connections, especially to production environment. Right. Metadata API calls for service account token, compute engine instance creation by service account, and calls to the IAM Credential APIs, particularly generate access token. These are all legitimate action in normal operation, but combination of them is rapid succession should be flagged for review. Right. Finally, environment segmentation. The reason the finding cover 2 project is because the IAM model was effectively the same across both. Production and staging should not share the IAM policies. Use separate GCP project, the separate service account, separate IAM bindings for each environment. Apply the principle of least privilege at the environment boundary, not just within the each environment. A developer identity that needs access to staging should not automatically have the visibility into the production resources. Alright, let me bring everything together. The title of this slide says it best. This is more than just an SSH bug. What started as a finding about misconfiguration OS login permission turns into demonstration of why GCP IAM hygiene matters at every layer of your cloud environment. A single non-admin identity, a test user, obtain root access on every VM in 2 separate GCP projects using nothing but the standard gcloud command line tool. From that root shell, we identify an attached service account with VM creation right, use it to spin up a rogue VM with a high privilege identity, stole that identity credentials via the GC metadata service, and then use those credentials to impersonate a third service account through the IAM Credentials API. 3 service account, 3 hops, full chain. The blast radius of the chain extends to every resource those service account can touch. Storage, database, secrets, VMs, and potentially the cloud control panel itself. And the entire attack is scriptable, repeatable, and requires no custom exploit code. The fix required action at multiple layer as well. Revoke osAdminLogin from non-admin identity, audit your entire VM fleet, not just the testing instance, lockdown service account attachment and creation, remove transitive trust between service accounts, strip unnecessary token creator grants, hide enumeration access, enable detections, and segment your environment properly. If you are running a GCP workload, run a quick IAM audit right now. Pull up your IAM policy, search for osAdminLogin, and ask yourself whether every identity that has it actually needs the root shell access to your VM feed or not. In most cases, the answer is going to be no. That's a wrap on this video. If you found this useful, hit the like button and subscribe. Thanks for watching, and I'll see you in the next one.